for the final runner of this panel, Vincent Christlein, will switch back to English. Again, you have the chance to get a receiver for the translation if you like to listen to his talk in German. Vincent Christlein studied computer science and received a PhD from the University Erlangen-Nuremberg. And since 2018, he has been working as a research associate at the Pattern Recognition Lab. And he was promoted to Academic Councilor in 2020, leading the Computer Vision Group. And in his talk, he will bring us back to the very focus of machine learning, after all, the human being and its body. And we're excited for your lecture, Pose Estimation for Artworks Retrieval.
Thank you for the introduction, and thank you for being here. So my talk will focus on pose estimation for artworks retrieval, but before that, I just want to highlight that I'm heading the Computer Vision Group, which actually does quite a lot of diverse things in computational humanities. So we also have a group in document analysis and also working with advanced digitization technologies like scanning with 3D CT scans, and then trying to make things visible which might be hidden in the object itself. Okay, but now let's come to art analysis, and the talk is partitioned, I would say, in 3 parts. So talking a little bit about pose estimation with the application on Greek vase paintings. Then we go a little bit beyond pose estimation. That's because it's a little bit going low level from the high level clip, going a little bit low level. And then we're trying to go a little bit beyond again. And at last, I want to talk what we are currently working on in the Oda Europa project, where we also focus on smell gestures. Okay, the main work I'm talking here about is actually done by Pratmesh Madhu, so I want to highlight him here. His thesis is about pose estimation and bringing these different disciplines also a little bit together. Okay, what is actually pose estimation? So it's a very classical computer vision problem. And so the goal is to identify certain joints. So you want to find, for example, points, certain key points in of the body, like nose, neck, left arm, right arm, and so on. And there are 2 certain ways that exist, So you can either do pose estimation on a bottom-up approach, and this is where the very famous OpenPose network also is building upon, so that you try to first detect key points and then trying to split them up in useful parts that are belonging to each of the bodies in an image. In contrast, there are top-down approaches available. This is also the approach that we chose. So there you first detect persons, and then only in the persons itself you then find these key points, so these certain joints, which are then parsed and give you the poses in the end. Both approaches have their pros and cons. So this is the con of this would be that you have to so if you have errors in your person detector, then this might propagate through, and the poses might not be available. On the other side, with the bottom-up approach, you also have problems then if you have mixed persons, that the poses also get mixed up. So it's not we chose that one because we liked it, that approach, but the other ones could also be useful. Actually, it's not true. We also use the other one as well, but both are useful. Okay, let's see how we applied that on Greek vase paintings. So we actually worked together with classical archaeologists, and they have many of these Greek vase paintings, and we wanted to make them more searchable for them in the respect of poses. So if you have these scenes, for example, Divine Pursuit scene here on the left side, and then comes Leading the Bride, and on the right side you have 2 wrestling scenes. you have these specific characters in their poses. And the question is now, can we just apply here, in this case, open pose network? And you see it does not really work on these vase paintings. So one idea was you could unfold the vases and then make them flat, if that brings something. But for us, this also did not really solve many of these issues. What we actually liked would be something like that. So full body postures on these vase paintings. And at that time, also style adaptation methods were quite big. And therefore, we also decided to use this as a manner of transferring knowledge that we have on contemporary data sets, like the big COCO data set is one data set that can be used. So on the left side, we have basically the content images of a big data set where we have annotations of the poses and also of the persons. And then we are using style images like from Greek vase paintings and get some form of stylized new data set. And we called that also a styled COCO data set. From the technology point of view, that we just used adaptive instance normalization. That is a very classical style transfer method. And having now images with bounding boxes and postures, which you see on the bottom, we do a two-step approach. So we have this data set of styled COCO and person data set. Then we compute one model that does the person detection and another one which is then doing the actual pose estimation called HRNet, and then you can parse the poses. So we have two models, and additionally in a second step we asked our classical archaeologists to also annotate as a few images. I don't know the numbers, I think we had about 300 persons annotated, and then also annotated for us the poses. And with this we can then fine-tune the first models of the first training stage and generate then two new models, here in this case A star and B star, and get a new output out. And if we do this, we see that this actually works really well in contrast to just the baseline approach, which barely detects here the poses in these vase paintings. And now let's come to the retrieval stage. Here, this can of course also be used as retrieval. Yeah, so of course in the first stage we have to run the person detector, and afterwards we can now find, for example, the fleeing character here of the pursuit scene and see if we get similar matches on Greek vase paintings. And that worked astonishingly well here. Of course, this is a little bit cherry-picked, this example. There are, of course, outliers. If you have a look at the raw numbers, we see that we are still far away from being perfect. Yeah? So our models here so left side you see on characters, and on the right side you see on scenes. So we had 15 characters and 5 scenes on a data set of about 300 images. So that's still rather small from the numbers here, but from baselines to this two-step approach, we gain about 15%. The difference is not so much if you just use the fine-tuned models. So this is the middle column here, the middle row with fine-tuned. I don't know. Oh yeah, you see my mouse. Yeah. So this tuned model, that would be if we just would use the data set that we additionally annotated. It just highlights that this two-step approach is a nice way to improve the recognition rate. Let's go a step back. So this is actually also, we have a tool developed, and you can unfortunately not try it out right now, but we have a demo also running on our systems. If you like to play around, maybe you can send me a mail. Okay, let's go a little bit beyond now pose estimation. towards image composition, and we are also leaving now classical archaeology towards art history. So we want here now assist in discovering semantics of an underlying scene, and very popular works was the work of Max Imdahl, who analyzed Giotto's frescoes, and in this way finding, for example, action lines in the scene, and also foci in the scene. For example, here where the angel looks downwards now towards Jesus, and we wanted now to see if we can maybe find ways to use pose estimation as a basis, because all these have somewhat a pose and they are looking towards something. So okay, the gaze and this information, using this to link semantically similar artworks. And as said, this is heavily inspired by the work of Max Imdahl, who developed methodology using an artwork structure to determine its significance. And he argues that visual cues, or the visual seeing, overpowers biblical or textual references by giving references here to the artworks by Giotto. And he explains how the structural relation between foreground and background and the distribution of colors and dynamism between the characters can help us to understand artists and their artworks. And we tried to solve this in multiple stages. So first we wanted to subtract the foreground from the background so that we have a background-foreground separation. We can do this again by our person detector, or by if we have directly, in this case, the poses of characters. And these also, the poses also generates us pose lines, and then how they are facing towards each other, and looking at the scene, we can generate action regions, and also finding possible centers of these actions. So we can also compare now the image composition here of Max Imdahl with ours. Of course, it's much different. Yeah? We cannot directly compare them, but it also, I mean, we have this line of sight of these different characters and a certain action region. Yeah? So the point here in blue, this action center, which actually fits quite well to where the most action in the scene is. What is a little bit missing is maybe this abstraction of these two levels, which now here Max Imdahl also had put in his abstraction. This is not part, or it's not part of our abstraction level here. So there could be also additional work be done in this regard. We also made a small user study. Okay, seems a little bit broken here, my bad. So we made a small user study based on 11 images, and we asked users, so experts and also non-experts, to draw us these action lines, and to see how now the algorithm works in comparison to users. And interestingly, that worked quite well, so you can then compare these lines also and see how far away are we from the lines drawn by the users. And so here with the Kiss of Judas, it worked rather well. Yeah? So the center also of this action center was also found very good, very well. And another example, so where it also showed that users actually also draw quite different lines. Yeah? So we have these different angles of lines here, while we are only focusing here now on the main side of the two characters. And interestingly, you can also apply this technique on natural images. So you can also run the pose estimation, of course, on natural images and see if maybe we have in photography similar compositional elements than in artworks. And so this might be something to explore. It also has failure cases, which you see here in the bottom. Yeah, so this technique is certainly not perfect. Yeah, so here it finds a pose line which is not correct. And but of course, then additionally, we tried to use these pose lines as a manner to link now different artworks with each other. So using it for image retrieval. And our original method got a little bit extended, so we called it ICC++. But essentially, we're doing the same methods as before. We are extracting pose lines, and then here in this case, we have to normalize them because they might have different sizes, and in this way, make a similarity measure that can be then used to rank the images with each other. And I have here some numerical values. Of course, they often don't mean something if we are just using them, of course, to look how much does the method improve against here state of the art was this LATP from I think from Prague, University of Prague. And with this data set, they reached about 31 top 1 accuracy, while the ICC++ here gets around 40%. And this can be also, the nice thing, these two methods are totally interpretable. In contrast, if we add now deep learning-based methods, which is much harder to interpret, yeah. So, but you can also combine these two methods with each other, like a classical VGG19 deep learning neural network, and then use them and you just concatenate both encodings, so both embeddings, and then you can also use them in combination with each other. So let's have a look at also some visuals. So when we get this as a query, this annunciation scene, it nicely returns other annunciation scenes in our data set. So you might see that we have always these two pose lines of the characters and then one action line, which are very similar in these annunciation scenes. Of course, there are also bad results, yeah. So it's not everything is good and shiny. So what can get wrong? Yeah. So we can have, first of all, we could have multiple action lines, and there we have problems. Also, in this case, the artwork had here on the bottom also additional characters, which of course we were not interested in this case. So it depends very much on tuning also these algorithms maybe further to improve the results. Okay, lastly, I want to talk where else can we use poses for our for analyzing data sets. And this is a quite work in progress of my colleague Matthias Zinnen. He is, and I am also involved in the Ode Europa project. So the Ode Europa project is an EU project that tries to gain knowledge about the cultural heritage or intangible cultural heritage of smells. So smell occurrences in texts and smell occurrences in artworks shall we bring together in a certain knowledge graph and make accessible, and as well can be then used for curators of museums to build special shows bringing these specific smells. Also, if you want to visit, there's currently in the Museum of Ulm has a smell exhibition. Very much, I liked it very much. So I can only recommend it. You can also directly check it out. The most or a lot of content is already accessible in explorer.oderupa.eu. I don't know if it works right now because there is an update today in the morning, so I'm not sure if you click now on it, if it works. They promised me that it should be done by now, but yeah, I don't know. From a computer vision perspective, our project part is involved in analyzing these artworks. And there are different categories, you can say. We actually have 4 categories. 3 of them I've depicted here. So fragment spaces itself are inherently smell related. For example, here the smell of the ocean in this sea scenery. Then we have olfactory objects. This is actually our main focus in this project because many objects are somewhat related to smells. And lastly, we have smell gestures. For example, if someone holds something towards his nose or is holding the nose because it's a disgusting smell or something. And maybe a 4th category, which is not visible here, is about indirect smells from iconographies where we know it was a bad smell. For example, the resurrection of Lazarus, which has bad smells in the text, but we know that it's a bad smell. And we want to find these smells here in artworks, and postures here come again because here we want to use pose estimation as a manner for detecting when someone is really sniffing something or is holding the nose. Unfortunately, these pose estimation models are not so good in these details of the hands. So currently we are struggling a lot here, and it's working not really well so far, but this is ongoing research here. Okay, this brings me to the end of this presentation. I started from image retrieval and then go to the semantic level a little bit upwards regarding scene understanding, where we try to link art images via compositional elements and maybe also finding smell references in artworks. Thank you very much, and I hope I don't hold you back from the lunch too much.
No, absolutely. Thank you, Vincent, very much for this, or those very different additional perspectives on how to work with image recognition and retrieval. I find that very inspiring. Never thought about this way to approach pictures or iconography. Even though it's very difficult for me now not to think about how I'm standing here right now in front of people. Try to get that out of my head. Maybe you have a question just to make me forget about my own pose or your poses. Any questions for Vincent?
Everyone is hungry.
You're hungry? That is all right. That is all right.